Today, we're diving into a really tough diagnostic challenge, 4 metabolic emergencies that can look so similar it's scary. Getting it right is critical because the wrong move could be fatal. Let's get into it.
Okay, so picture this. 4 patients roll into the ER. They're all confused, lethargic. Their entire energy system is in complete chaos. The symptoms are overlapping, the stakes are incredibly high, and it's your job to solve the mystery. How do you find the right diagnosis when all the clues seem to point in different directions?
All right, here are our 4 suspects. On the surface, they're all about the body's fuel management going haywire. But if you look closer, each one is a completely different kind of biochemical breakdown. We're going to investigate each one to figure out its unique signature.
To crack this case, we have to start with the one fundamental principle that controls everything. It all comes down to this hormonal tug-of-war between 2 main players, insulin and glucagon.
Think of it like this. Insulin is your storage manager. You eat a meal, and insulin is like, okay team, let's pack away this glucose for later, and it slams the brakes on burning fat. Glucagon is the total opposite. It's the release manager. When you're fasting, it's shouting, release the glucose, start breaking down fat. The ratio between these two, that is the master switch that decides everything.
So, keeping that master switch in mind, let's go back to our 4 suspects. We're about to see exactly how their hormonal balance gets thrown off, leading to a complete metabolic crisis.
First up, we've got DKA. This is the classic emergency you think of with type 1 diabetes, and the root of the problem here is a near total absence of insulin.
You can see the domino effect right here. With no insulin to say stop, the body thinks it's starving, so it starts breaking down fat like crazy. This just floods the liver with raw material, so much that the cell's whole energy pipeline gets clogged. A molecule called acetyl-CoA gets totally backed up, and the result, this massive, out-of-control production of ketones, which turns the blood dangerously acidic.
Next up is HHS. You see this one more in older patients with type 2 diabetes. And the key difference is really subtle, but it changes everything. It's not an absolute lack of insulin, it's a relative one.
So, that tiny little bit of insulin that's still around, that's the whole story. It's just enough to prevent that massive fat breakdown so you don't get the crazy ketone production and acidosis like you do in DKA. But, and this is a big but, it's not enough to control blood sugar. So glucose just skyrockets, pulling tons of water out of the body's cells and causing absolutely life-threatening dehydration.
Okay, our third suspect, starvation ketosis, is kind of the odd one out here. Because unlike the others, this isn't some pathological crisis. It's actually a pretty amazing survival adaptation.
Right? So when you fast for a couple of days, your body is smart. It starts making ketones to keep your brain fed. But the key word here is controlled. The system has feedback loops. The ketones themselves, plus a little bit of insulin, stop the process from spiraling out of control into dangerous acidosis. It's a regulated, life-saving process.
And finally, we have alcoholic ketoacidosis, or AKA. This is a really unique situation. It happens to people with chronic alcohol use, usually after a binge that's followed by a period of not eating anything. The biochemistry here is just wild. When your body metabolizes all that alcohol, it throws the cell's internal chemistry, this NADH to NAD+ ratio, completely out of whack. It's like flooding an engine with the wrong fuel. And this one change causes a triple whammy. It blocks the body from making new sugar, it cranks up lactic acid, and it drives the production of ketones. It's just a perfect storm for acidosis, but often without the super high blood sugar you see in DKA.
So, we've investigated all 4 suspects and their motives. Now it's time for the climax. Let's look at the hard evidence, the lab results, that will let us tell them apart for good.
The first huge clue is blood glucose. If you see a number this high, we're talking over 33 millimoles per liter, your number 1 suspect has to be HHS. That extreme hyperglycemia is its calling card. Okay, the next critical piece of evidence is the anion gap. It's basically a way to measure the acid-base balance in the blood. And a high anion gap, anything over 16, is a major red flag. It's shouting at you that there are extra acids in the blood. And in this case, those acids are ketones. This points the finger straight at DKA and AKA.
And here it is. This table is the solution to the whole puzzle. Let's trace the fingerprints. Look at HHS. Glucose is off the charts, but the pH is totally normal. Now check out DKA and AKA. Both have a low acidic pH and a high anion gap. So what's the difference? Glucose. It's high in DKA, but it's normal or even low in AKA. And then you have starvation ketosis. Low glucose, tons of ketones, but, and this is crucial, the pH stays normal. Each one has a distinct, undeniable signature.
So why is getting this fingerprint exactly right so important? Because a wrong diagnosis leads to the wrong treatment, and that can have absolutely devastating consequences.
Just look at how different the playbooks are. DKA needs insulin right away. But with HHS, the number 1 priority is slow, careful rehydration. Give insulin too soon and you could cause serious harm. And for starvation and alcoholic ketoacidosis, you know what the cure is. It's not insulin, it's sugar. Giving dextrose tells the body the starvation is over and shuts down ketone production. This is why the diagnosis is absolutely everything.
And before we wrap up, here is a massive clinical pearl you have to remember. The main ketone in both DKA and AKA is something called beta-hydroxybutyrate. Here's the problem. Your standard urine test strips, they can't see it. They only detect acetoacetate. This means you could have a patient in severe AKA, but their urine ketone test comes back negative. It's a classic and dangerous clinical trap.